Our first problem is a fairly simple one, but I wanted to start off with one of those to introduce this process of solving these kinds of problems. So let's read through it. Harry drives to Atlanta in 7 hours, period. Coming back, it takes him 8 hours, but his average speed is 7 miles per hour slower. How far is it to Atlanta? All right, so a lot of books will recommend you start off with some kind of picture, some kind of sketch. All right, so here is Atlanta. Here is, well, where is here? Shall we call it Hillsboro? Or you can fill in the blank. I don't know how far it is from Hillsboro to Atlanta, but it's probably about a good 8 hours. I've made that trip a number of times on my way to Florida. So, I'm not sure how this diagram is going to help because I have two trips. I'm coming to Atlanta and I'm going back. And each trip has one thing in common. For one, it has the same distance equals rate times time, distance equals speed times time relationship dictating this motion. Well, it has something else in common. Both trips are the same distance. And that'll be an important observation later on. We can use that, I believe. But I don't see how a diagram in this problem is going to help a lot. So let's not worry about it. What I'm really going to worry about is writing out the speed times time equals distance for each trip. Because that's the relationship for each trip. And it's the only thing I can use to build these problems. All right, so let's talk about going to Atlanta, first of all. And going to Atlanta, what's going on? Well, he's going at a certain speed. They didn't tell us what the speed is, so we'll have to make up something, won't we? If we don't know what the speed is, but if we need a speed quantity, then we're going to have to call it a variable. So already I'm stuck. I'm going to need to define a variable for the speed he's driving to Atlanta. And why don't we call that x? So I'm going to let x equal to the speed to Atlanta. And this is in miles per hour. Okay, that's sort of understood, I think, miles per hour, but I'll put the units in here just in case, just to be safe. All right, so Atlanta, we know he's going to Atlanta, he's going at this speed. And how long does it take? Well, it takes him 7 hours. And so let's see. He drives x miles per hour for 7 hours. All right, now from this we can get the distance. Because if we multiply these together, look what happens here. So I'm going to say that this is a distance of, and I'm writing the words out here, x miles per hour times 7 hours. And again, I can't stress this too much. When you multiply these together, look at the units. This is a numerator unit. It cancels the denominator units. And I get miles. And what is miles? Miles is distance. So that's the distance of 7x miles. All right, so he has driven 7 times x miles. Now, if we can just figure out what x is, we'll be in good shape. Actually, x is sort of the only unknown in this problem, which is kind of funny because in a sense the distance is known. The distance is the same for both trips. But then again, the distance is not known. We'll have to figure that out later, but for now it's kind of known because it's the same for each trip. But I have an x, and that I don't know. I don't know how fast he's going. All right, so that's the trip to Atlanta. Now, going home, we're coming back, and I'm running out of room here. But so I'm going to skip writing all these sentences out. But if you take his speed, and his speed is now what? It's 7 miles per hour slower than it was up here. So his speed coming home would be what? It's x minus 7 is the speed coming home. And notice that I'm taking x miles per hour, subtracting 7 miles per hour. My units are consistent. So coming home, his distance is, and we have a speed, x minus 7 miles per hour times how long? It took him 8 hours. 8 hours. So again, the hour units cancel, leaving a distance in miles. So we have his speed as time, and that gives us distance, which is 8 parentheses x minus 7 miles. All right, so again, let me recap. 2 different trips, and we need to incorporate speed, time, and distance. But distance comes from multiplying speed and time together. So what was the speed up here? He's going x miles per hour. How long did it take? 7 hours. That was known. Down here, a slower speed, 7 miles per hour less. Took him 8 hours, and there's his distance. So we have distance, and my board's a little cluttered because it's small, but here's the distance going to Atlanta. Here's the distance coming back home. And how do we now put this together? Well, those distances are equal, aren't they? Okay, going to and coming back, the distances are equal. That allows us to do what? It allows us to set these equal to each other in this problem. So, unfortunately, I have to do some erasing here in order to make some room here. Well, I'm going to erase the problem. I'll continue up above. Okay, so the distances are equal. I'm just going to write this in as an observation. Distances are equal. I wouldn't say that's necessary to write that in if you're working a problem, but I'm going to give you notes here. Because the distances are equal, 7x miles equals to 8 times x minus 7 miles. So miles equals to miles. If one side was miles per hour and the other side was miles, I could not set miles per hour equal to miles. It would be just junk. I couldn't get the right answer that way. But miles does equal miles. All right, and like I said, in solving an equation, well, setting up an equation is 2 different ways to say the same thing. Here, we found 2 different ways to describe the distance between the 2 places, between home and Atlanta. 2 different ways to describe that, and that set up our equation, which we can now solve. So this is a pretty easy equation to solve. Multiply it out. 7x is 8x minus 56. And with a little juggling, it's easy to find that x has to be 56. So his speed to Atlanta is 56 miles per hour. If that was a question in the problem, we could answer that. He drove 56 miles per hour on average to Atlanta, and coming back, he averaged 49 miles per hour. So, when I had kids, 49 was a pretty good speed, and when I drove to Florida without young kids, then 56 is more the average speed when you take into account stopping to eat and get gas and things like that. All right, so this is a pretty reasonable result, I think. All right, well, we're not done because we haven't answered the question, how far is it to Atlanta? Well, 7x gives us that distance. So the distance would be 7 times 56. So let me write out the answer to the problem. And I wish my board wasn't so cluttered. But here's my answer. The distance to Atlanta is, and it's 7 times 56, which is, I think that's 392 miles. Okay, 392 miles. Actually, this is time, hours, times miles per hour. Again, we have, hours, yeah, hours times miles per hour. The hours cancel, just like it does here. And I get miles, so that justifies calling that miles. 392 miles. Now, how can you check it? Well, he's going 49 miles per hour coming back. And it takes 8 hours. So if 8 times 49 is 392, then your answer has to be correct. And it is. You can check that. So it's, last thing you should do is check your answer. How do you check your answer? Well, really, I should say you're supposed to go back to the original words of the problem. All right, so let's see. He drove to Atlanta in 7 hours at 56 miles per hour. Multiply those together, that's 392 miles. Coming back, he went 7 miles per hour slower, that's 49 miles per hour. Took him 8 hours. That would be a distance also 392 miles. So don't, I would not check your equations, because what if your equations are wrong? Then you fooled yourself. Go to the words of the problem and try to verify your answers that way. All right, so we worked through it. And I capitalized my first letter of the sentence. I put a period at the end, and it really is a sentence, so it's communicated well. We checked our answer, and so therefore, we're done.